In our last class, we talked about two types of inheritance, that is single inheritance and multiple inheritance. Today, we will see what is a hierarchical inheritance, what is a multi-label inheritance, and hybrid inheritance. So before going to the rest three, let's recap a bit. Single inheritance means you will have a base class, and from there you will derive a child class or derived class. Example is just the one we practice. If there's an animal class, and from the animal class, if we derive a dog class, that's a single inheritance. Then we have, so this is the syntax: class derived class name. In our example, it was dog. So class dog. Visibility mode or the mode of inheritance is public, and base class name, that was animal. So class automobile, public; vehicle, class dog, public; animal, so on. Then we have this multiple inheritance. In the multiple inheritance, one class inherits from two other classes, okay, or multiple classes. It can take three classes, okay, but one class will be derived from multiple classes. That is a multiple inheritance. In the syntax, the basic structure is same: class, derived class name, visibility mode, visibility mode. So if you are inheriting from two classes, you have to write how you are inheriting from both classes. So for example, in this case, in both cases we are inheriting father and mother, and both cases we are using public. You can use this one private, okay, or you can use this one protected. It's up to you how you want to inherit the properties, okay. Next we have the next one we have is hierarchical inheritance, the one that we just did, in the derivation of several classes from one class. So in this last example, in case of animal, from the animal class we have derived a dog class and a bird class. So this is an example of hierarchical inheritance. That means one class, multiple classes are derived from one class. So this is called hierarchical inheritance. So in this figure, the class y and z both comes from x. So y is a little bit different, z is a little bit different. Just like the way dog was a little bit different, a bird was a little bit different, but both those were animal. So the syntax is simple: the class derived name and the visibility mode of base class. Now here's another one, that is we call multi-label inheritance. In this case, what happens is that class x first created, then class y inherits the class, and then z inherits the class y. So there are different levels of inheritance. It can be 2, it can be 3, it can be 4, okay. So when a subclass is derived from a base class, which itself is derived from another class, it is known as multi-level inheritance. In our example that we practice, you can think like this: we start with the animal class, and from the animal class we actually derive bird class, okay. So this is, let's assume this is the animal class and this is the bird class. Now, just a minute. I was saying that from the animal class, we have, let's write it down. So first we have this animal class, and then from the animal class, we have derived bird class, let's assume, okay. Let's assume dog class, okay. And then from the dog class, okay, we have, there are different types of dogs. So we have, less, for example, we have derived German Shepherd, okay. So this is one class of dogs which have a special ability or a special type of dog. So in this way, no, we can inherit one class, and then from that class we can inherit another class, and so on. So this is called multi-level inheritance. Then what we have, so the syntax is same, there's no difference in the syntax. The first public x, x was created, and from that x we inherited and created y, and then from class y we created z. And finally, we have this hybrid inheritance or the multipath inheritance. Sometimes what happens, all these four types of inheritance will sometimes actually can't solve a problem, or sometimes we use a combination of this inheritances: multi-level, hierarchical, multiple, and so on. So when we use a combination of this first four inheritances, we call it hybrid or multipath inheritance. Just look at this one. In this example, class W was created first. Then from this W, we created X and Y. And from X and Y, we created Z. So from W, we first created X and Y. And from that X and Y, we created Z. So if I just focus on this part, okay, from W we created two classes. Okay, so we can say this is a hierarchical inheritance from the definition. So this part is a hierarchical inheritance. From one class we are creating multiple class. Again, if I go for this part, from X and Y we're creating Z, we can say that this is a uh, this is a wait yeah, this is a multiple inheritance. That means one class is derived from multiple classes. And then if we look at the overall picture, okay, the overall picture, first one class was created, from that there was another class was created, and finally from that class another class is created. We can say this is a multi-level inheritance. So as you can see, it's hard to define which type of inheritance this is, so that's why we call it a hybrid inheritance. So this is all about the definition of inheritance. Now we'll go to the constructor. Now, before going to the constructor, I will start with the code. Let me write down the code first. Before going to the code, let's see these 2 points that we need to remember whenever we're handling the constructor. The first one is whether the derived class default constructor is called or not. Let me change the color. Just a minute. Yeah. So this is our points to be remembered. So whether the derived class's default constructor is called or parameterized constructor is called. So we can see there are two types of constructor. We have already learned. One is the default constructor, where we have no parameter. Okay, whenever we don't write any constructor for a class, the compiler provides the default constructor. And then we have this parameterized constructor, where we pass values to initialize to 0 or for any other values. Now, whether from the derived class, whether you have a default constructor or a parameters constructor, in all the time, the base class's default constructor is called. So whether you call the whether you have a default constructor or the parameters constructor, this base class default constructor will always be called. The main point here is that if your whether you write any constructor or not, the base class's default constructor will always be called inside them. Okay, now next thing is, if the base class, okay, if you have a parameterized constructor, okay, inside the base class, so when you derive that class, okay, you can call that constructor as well. And in that case, you must mention explicitly while declaring the derived class parameterized constructor. So this is the two case. If I write down in sense of code, in the first case, what we have a class, parent class with default constructor. And then in the second case, we have a parent class with parameterized constructor. So these are the two cases we have. In the first case, we don't have any constructor for the parent class, that is a default constructor. And the second case, we have a parameterized constructor. So we'll see in what happens in both cases, how we can initialize values and how they are called. So I hope the question is clear. Now let me go to the code. Before going to the details of how we can call the constructor, let's see for a normal case how the constructor works. So for example, in this one, we take this simple example. So we have a class and base class which have only one variable, integer x. And in the base class, this is a constructor as it has the same name as the class. Then whenever this constructor is called, we have kept a console output that will print this is a base default constructor. Then we have a derived class, okay, named derived, which comes from base. Again, we're using the public mode of inheritance. Here we have only one variable, that is y. And in the derived class, we have a constructor. Okay, that is a default constructor. As there's no parameter, okay, it will just say derived default constructor. And there's another constructor that is called parameterized constructor. Okay, and then in the main class, what we do, we first create an object of base class, then we create an object of derived class, then we create another object of derived class with a parameter. So this is our three object calls. So normally, just forget about inheritance. Okay, normally if we create three objects of three different classes, three constructors will be called. For each of the objects, we call the constructors, the default constructors. Now let's run the code and see what happens. Okay, let me share the output with you as well. So as you can see in the output, for three classes, okay, we have used three function calls, right? there should be three printf, but here first we have the base default constructor, then we have the base. Oh wait, let me share it another way. Just a minute. Let me run the code again. Yeah, I think you can see it side by side now. Now, if I just keep it side by side, so first for the base B, okay, the first constructor is called because we are creating an object of the base class and it will call the default constructors as we have here. Okay. Then for the second case, okay, derive D1. So whenever we create an object of derive D1, what it does, it actually goes here and it calls its constructor, derive default constructor. But as you can see, before printing the derived default constructor, it prints base default constructor again. So what is the reason? Okay, the reason is whenever, as I said in the 2 points, that whenever a derived class called, okay, it automatically calls the parents class default constructor. And then for the second case, it's also same as well. Whenever we call the parameterized object, create, then you see first the base class default constructor is called and then base derived class parameterized constructor is called. To understand this more easily, what I will do now, I will erase this. Okay, so I will call one by one. Let's first call the base function. Let's see what happens. When we create an object of base class, the default constructor of the base class is created. Simple. Okay, let's close this one. Let's comment this one, and now let's create an object of derived class. So when we create the object of derived class, you see we're not doing anything else. So it's calling by default the base class default constructor. It's calling the derived class default constructor because we are not passing any parameters. Okay, now let's go and go for the third one. So when we are calling the parameterized, we are creating a initializing a value with a parameter that is d210. In that case, base default constructor is called and derived parameter as constructor is called. So we are now here in this one. Now there can be an explanation for this one because the base class only have one constructor. So it doesn't matter which one we call, whether it's a derived class D1 or derived class D2. If we run the code, in both cases, you see base default constructor is getting called. Okay, so that is the reason maybe. Okay, so let's try and create a derived class, a base class parameter as constructor. So if I just paste it here, base, so now in the base class, we also have a parameter as constructor, and let's see what happens. Let's first use this one. Sorry, let's first start with the first one. That is this one. So let's run the code. You see, only the default constructor is getting called as usual, okay, because we are not passing any parameter. So let's then after this one, for the base class, okay, let's pass a value. And I think all of you can guess. Now we will call the parameterized constructor for the base class. You see, the base parameter constructor is being called. Then now let's start with the inheritance part. So now we will call this derived D1 with no parameter. So from the base class, we should call the default constructor, and from the derived class, we also should call the default constructor because we're not passing any parameter. And when we don't pass any parameters, the default constructor is called. See, in both cases, we're calling the default constructor. And now it's time to check whether our intuition was correct. So we're now using the default class with a parameter. Now from the base class, will it call the default constructor or will it call the parameter as constructor? So now we have to think. So let's run the code and you will see that still it's calling the default constructor. The parameter as constructor is not getting called. So what's the problem and what we can do to solve it? So before that, I will show you in the next class how to solve this problem. For now, let's say that whenever you inherit a class, okay, every time, okay, whether you create any constructor of your own or not, it will always call the base class constructor. So that's why we have created this. Okay, that we, if we only just create this two objects of derived class, and if we run the program, we have seen that automatically what they do, they call the default constructor of the base class. So that means the default constructor of the base class will be always called. This is number one. Point number two, what happens in case of destructor? The destructors are actually called in the reverse order. In this example, as we have seen, that first, even though this is the object of derived class, first we call the base class. After printing the base class, then we go to the derived class. In case of destructor, it's opposite. We first destroy the child and then we go for the parent class. We'll see an example, but for now, let's stop here.